Hello there. Let's do IP version 4 so that we can recognize and work with these addresses for our A+ course and obviously for your exam. Now if you're new here, please like and subscribe. It really does help the channel out. Without any further ado, let's get into it. So first of all, let's talk about the structure of an IP version 4 address. An IP version 4 address is a 32 binary bit value that we usually write in dotted decimal notation because it's just that little bit easier for us human beings to read. The address is broken down into 4 sections that we refer to as octets. Each of these 4 is 8 binary bits in length, and we use a dot to separate these octets, hence the name dotted decimal. Now the decimal values will always range between 0 and 255. It'll never be below 0 and it'll never be above 255. So if you do see a negative number, incorrect, not possible for an IP version 4 address. And if you see 256 or higher, impossible. You need a 9th binary bit to do that. Now considering you're doing the A+ certification, you don't have to worry about converting the IP version 4 address into binary. But if you want to see how to do that, you can jump ahead to my Network Plus series, where I cover that process in the numbering systems video. But for the most part, you can get away with looking at everything in decimal, at least for A+. Now, the IP version 4 address space gives us a total of 4.2 billion IP addresses. But what does this address space look like? Well, we've got a grouping that we use on the IP version 4 addresses. We refer to these groups as classes. Class A begins at 1 and goes all the way up to 126.255.255.255. Class B begins at 128.0.0.0 and goes all the way up to the end of 191.255.255.255. You'll notice that if you pay attention to the first number of the IP address, that helps you recognize the class this address belongs to. And with Class C, you've got 192.0.0.0 going up to the end of 223.255.255.255. Then you get Class D, which begins at 224 and goes up to the end of 239, and Class E, which goes from 240 up to 255. Now the thing about Class D and Class E is you won't see them that much in the real world. The reasons being is both of them were reserved. Class D was reserved for multicasting, which is a special kind of communication, and Class E was reserved for research and development, so that the entities that help create new protocols and services for the internet can safely test them out without breaking the internet. Now, in terms of communication types we get with IP version 4, you get a unicast, a broadcast, and a multicast. With a unicast, that is a one-on-one conversation. With a broadcast, that is a one-to-everyone conversation. And with a multicast, that is a one-to-some. The way it works is that if you are running a particular service on your device, and somebody wants to talk to you and that service, they will send a message to that particular IP address that is tied to the service. That IP address will usually be part of Class D. Now, an important thing about the classes is the classes come with something called a Classful subnet mask. The purpose of the subnet mask is to divide your IP address into 2 parts, a network address portion and a host address portion. The Classful subnet mask for Class A is 255.0.0.0. The Classful subnet mask for Class B is 255.255.0.0. And for Class C, it is 255.255.255.0. A is the first letter of the alphabet. There is 1 255 in the subnet mask. B is the second letter of the alphabet. There are 2 255s in the subnet mask. And C being the third letter, there's 3 255s in the subnet mask. Because Class D and Class E aren't really available for use in ordinary network environments, they don't get Classful subnet masks. So that's why we put a line through them there. So the network address and host address portions of an IP address is the purpose for the subnet mask. What happens from a technical perspective is the IP address bits that logically AND with the mask are going to be network address bits. The IP address bits that don't AND with the mask are going to be part of the host address bits. Now the AND I've got written there, it's a binary arithmetic operator. You don't have to worry too much about it, but it is a term you might see used to describe how the subnet mask interacts. Basically what it means is that the parts of the address that align with the 255 in the mask are part of the network address, and the parts of the address that align with the zeros in the subnet mask are part of the host address portion. So the network address's job is to represent the whole network, and it will be common to all nodes or networkable devices in the same LAN segment or IP subnet as we sometimes call it. And the routers will rely on the network address to populate their routing tables and figure out how to get traffic to these networks. The host address will represent the individual node or device within that network, and it will be unique to that node within that LAN segment. No other device will have the same host address portion, otherwise you're going to have a weird conflicting issue. And it is usually used by the last router that connects to that LAN segment to help get the traffic to that node. Now, you have your Class A subnet mask. So for Class A, remember that's from 1 to 126. And the subnet mask is 255.0.0.0. If we stick an IP address above that, we can imagine a line after the last 255. And everything to the left of the line is part of the network address. Everything to the right of the line is part of the host address. So we've got the 10 network, and the host is .1.0.40. And if you're looking at this and thinking, so I could vary the network address between 1 and 126 and be in Class A. And then we've got those three numbers that can be 000. And when we get to 00255, we can then go to 010, and we're still in the same network. Now this means that we have very few networks in Class A, but there's a lot of hosts in each of those networks. You're looking at around 16 million hosts per Class A network, which is a lot. I have never personally encountered a single physical LAN segment that needs that many addresses. Then we have our Class B subnet mask. Class B, remember, is from 128 to 191. And Class B subnet mask reads as 255.255.0.0. If we were to put an IP address above that, like 172.168.63, and imagine a line after the last 255, everything to the left of that line is the network address, and everything to the right of the line is the host address. This means that we have more networks in Class B than we do in Class A, but each of these networks has fewer hosts in them. You're looking at around 65,000 hosts per network. 65,534 to be exact. And then when we look at Class C, which remember Class C is from 192 to 223, you're looking at a subnet mask of 255.255.255.0. So let's stick an IP address above it, like 192.168.125.11, and imagine that line after the last 255. Everything to the left of the line is the network address, and everything to the right of the line is the host address portion. So with Class C, we get many networks. But each of these networks has far fewer hosts in them, 254 hosts per network, which is still pretty reasonably large if you think about it. Chances are, if you're sitting on a home network right now and you check your IP address on your computer, it is probably a Class C network address. I'll put my money on a 192.168.something.something address. And if you think about it, 254 devices on a network is actually quite a lot. Now, one of the reasons why I might have been able to guess your IP address, or at least half of it, so well, is because I know which private addresses are used in home networks, or actually any private LAN for that matter. We have this distinction with private and public addresses. Private IP addresses were created to help extend the longevity of IPv4. Although 4.29 billion IPv4 addresses sounds like a lot, remember, there's way more than that many people on planet Earth right now. And even though a lot of people don't have access to a computer or the internet, those of us that do, a lot of addresses get used up so that we can have that interesting pleasure of internet connectivity. So the private IP networks were created so that we could use them on our LANs without wasting addresses for internet subscribers. The problem though is private IP addresses are not unique on the internet. And we rely on a technology called NAT that our routers can run that allows us to convert a private IP address to a public address when our traffic goes onto the internet. But when you have two computers on a LAN talking to each other, you don't need to have public IP addresses involved there. It would be a waste. Now, to help regulate it, public IP addresses are paid for and only allocated to ISPs through a rather interesting process. But when you do have a public IP address, you will be unique on the internet. Usually your router gets the public IP address and it runs the NAT service to translate between your public and private addresses. So let's remember the private and special addresses, and then we can figure out and remember the public addresses. Now, I always find it easier to remember the private and special addresses, and then the rest are going to be basically public. So the first one that's worth remembering is the 0.0.0.0 network. This is used as a default route, and most routers will have a routing table entry with this particular address in. Because of that, this entire network cannot be used for anything else. Then you've got the 10 network, which is a private network that you can use on your LANs, whether they be at work or at home. You don't need to get permission, pay for it, or anything like that. But you won't be unique on the internet because I can guarantee you plenty of other people are also using it too. Then you get the 127 network, which was reserved for loopback address testing. If you were to open up command prompt on Windows or a terminal on Linux and type ping 127.whatever.whatever.whatever, you'll get an answer. And the purpose of that is just to check that the TCP/IP services on your machine are working correctly and fine. If you don't get an answer, that means there's a problem with the TCP/IP services on that computer. Then you get the 169.254 network, which was reserved for automatic private IP addressing, or a PIPA. A PIPA is used when DHCP fails, and your computer has been set to use DHCP. Your machine will pick a 169.254.something.something IP address, with obviously the Class B subnet mask, so that you can have limited and local communications. Again, if you have a connectivity issue and you check your computer's IP address and you see it's 169.254, it means you've probably got an issue with your DHCP server, or there is no DHCP server on that network. Then the networks from 172.16 through to 172.31 are also private networks in Class B. We get a couple private networks in Class B so that we get more or less the same number of private host addresses that we get from that singular 10 network in Class A. Then for the 192.168.0 through to 192.168.255 network, it is also private in Class C. And we basically get the entire 192.168.something range so that we have loads of networks and more or less the same number of hosts that are privately addressable that we get in Class A and Class B with their private networks. Then we get Class D and Class E, which, as we mentioned earlier, were reserved. And, like I mentioned at the beginning of this list, the rest are public. So it's always easier to remember the private and special addresses, and then, if it looks like anything else, it is probably a public IPv4 address. Now, hopefully this serves as a good foundational introduction to IPv4. We will definitely be building on this further as we work through this course, and definitely in Network Plus. Remember, your IP addresses are logical addresses. They are following particular rules in terms of how they're allocated, so that makes them somewhat predictable. And it's the reason why we use them for routing traffic around networks, especially the internet. Those MAC addresses we mentioned previously, as great as they are not predictable, which means that they're kind of difficult to use for communications beyond the local LAN segment that you are connected to. So we tend to use a combination of the two, MAC addresses and IP addresses for network communications. Regardless, we're now sidetracking and starting to trend into other topics, so let's leave it there. I'd like to say thank you for watching. I do appreciate it. And if you have any friends, family members, colleagues, or peers, or anyone else that would also be interested in learning A+, don't be afraid to share this video with them. Otherwise though, I'll catch you in the next video.